Hey everybody, Harold here. Today in my SQL PyR series, I'm going to start with some of the more basic commands. Today I want to talk about select or column selection in Python, R, and SQL. As data analysts, we're constantly getting data from various sources. Best practices in retrieval say you should only take the columns you need and take them as close to your source as possible. This means if you're getting it from a SQL database, don't take the whole SQL database into Power BI. Just take the columns you need. To do this, we most often use a select command or some variant of select to select only the columns we need from a database. So let's see how we do this in Python, SQL, and R. So we will start in Python, pandas. I'll tell you right off, this is the worst. Not that I don't love Python, but pandas is not very versatile for this function. If you don't have pandas installed, run this command, take off the hashtag, uncomment it, and run it. And then run import pandas as PD. I'm working in Google Colab. It's free. You'll be able to run this notebook from my GitHub or create your own notebook and recreate it yourself. First, I need a data frame. So I'm going to take product list equals a dictionary. Product name is the key, and the values are a list. Red, blue, yellow balloon, black balloon. Same for ID and price. These are keys, these are values. This is a dictionary. I'm going to take that dictionary and turn it into a data frame using the pandas pd.dataframe from the product list. Then I'm going to call it my products. So we'll run that and we'll view my products. It's not very long. There it is, name, ID, price. If you want to select columns by name, you can do a single column. So my products, it's our data frame, product price is the column we want to see. One column data frame. Multiple columns, just separated by a comma, but they need to be in a list. So you need to double your square brackets. My products square brackets, and the list is also square brackets, product ID, comma, product price. If you want to select them all using index, you can use 0:. Uh, you could select using the Pandas loc function. Loc does it by name, so my products.loc colon for the rows, comma, list for the columns, indexing. Uh, so that's how you would do that with loc. iloc is actually indexing on the numerical index. So you can say my products.iloc colon for all the rows, comma, column 2 to the n. So product ID and product price. But that's really about all you can do in pandas. I like SQL much better. I like the syntax. So let's show you in SQL. Selecting all is select star. Got the my products. I'm in SQL Server. Messenger service. Got my products. My orders table in my SQL PyR database. These are available in my GitHub also. So let me execute that, show you what we're working with. It's the product ID, name, and price, 3 columns. Well, I only want to see the product ID column, so I'll select a single column, select product ID from my products. Uh, there we have it. Select multiple columns, select product ID, and you need to put a comma between your columns. And convention is to put it in front of the column name and not behind. So select product ID, comma, product name for my product. Product ID, product name. Order doesn't matter just because my table goes product ID, product name, product price. I can switch it around and do product name, product ID. If I want to rename it right there, I can use an alias and rename it while selecting. So select product price as price from my products. So now it's called price, not product price. These are all preparing what you want to do with the data before you take it out of here. Uh, that's it for basic select. There are two other variants. Top. I only have 4 rows in my table, but I could say select top 2 for my products. That gives me the top 2 rows. There is no order in this. You'd have to do an order by clause. We'll get to sorting in later videos. And there is, if you just go on right click on a database in anywhere, you can select top 1000 rows or edit the top 200 rows. That's just creates a top command. You do that. Select top 1000, what columns you want. So that's an easy one to just check out a database real quick, go in the tables and right click and say top 1000. And then there's also select distinct. Other languages mostly use these in as unique or distinct in other commands, but you can just do that here if that's what you're looking for. So my orders has duplicates in the product ID column, and you just want to know the distinct product IDs. So select distinct product ID from my orders. A100, B100, C100. Remember, D100 hasn't been ordered, and some of these have been ordered more than once, but that'll just give you the distinct product IDs. So I like that a little better, but what I like the best is the R. Uh, I think this is great. It's much versatile. It's much more versatile. So select in R in the tidyverse the best. For further information and examples, see the dplyr vignette, and here's a URL for you. There's great stuff in that vignette. Actually, dplyr is a part of the tidyverse, and the tidyverse has a lot of great vignettes if you're interested. We do need to install that package as tidyverse if we don't have it, and then import the tidyverse. So library will require tidyverse. We'll create that table. It's a table of 3 lists. Uh, you've seen it before, so let's look at it again. Create it in R, and let's take a look at it. My product. So here's our little tibble down here. In base R, it is extremely limited. You can use the $sign to do column by column name, and you get a vector. You could do it by indexing. You get a small tibble. You can use these multiple forms. They just return vectors or little tibbles. If you want forms more versatile for analysis, you really want to use the tidyverse, and you want to use the dplyr select command. You want to select all, well, really, you can just say my products. That'll give you the whole table. Let's see what kind of data class type that is. It's a table data frame, a table, and a data frame. Great for whatever you want to do for analysis. Instead of select all, you can say select the helper function everything. That gives you, again, the whole table. You just want one column. Uh, I forgot to mention the pipe. Pipe is part of tidyverse. So when I say select everything, I'm piping in my products table to that command. So it's selecting everything from my product. Every time you put a pipe, everything below flows back to what's above. A single column, my products, select product name, pipe in my products, product name. Multiple columns, my products, pipe, select product ID, product name. So that's pretty generic. But now we get to where it gets better. You can use the colon operator to select a range with name columns. So product ID through product price. Well, that's all of it. I should have just put name. So now it's just product ID, product name. So you can use the colon operator for a range. You can use the exclamation point operator to exclude everything, to exclude things, select complementary columns. So keep everything but that column. I want to see if I wanted to select product ID and name and not product price, well, of course I could select product ID, product name, but that's two columns I have to type out. Instead, I can just put exclamation point product price, and that gives me the other two columns. There's a lot of other helper functions. Not so helpful here, but if you imagine I'm using these, well, they are helpful here, but imagine I'm using these on a large database with 50 columns. I can't even get it across the screen. So I could say last call, my product's select last call, price, $1.99. My products, I can do starts with. So my product starts with TR. Well, we're going to get all of them probably, but so product ID, product name, product price. My product ends with. You can do ends with. My product select ends with ice. We got the product price column. Contains any kind of string. Select columns that contain the string NAM. Product name. It's got NAM in it. You can use regex. I'll just use $sign. It's a simple one. It's same as ends with, but you can do a lot more complicated regex. That's regular expressions. So my product, this is matches. My products pipe select matches price $sign. That should give us the price column. If you wanted just the columns that are numeric, you can say my product select where is numeric. And it just gives me the product price column, which is a double, which is a numeric data type. If you, let's see, I could show this. The is dot has a lot of other arguments too, so let's see, call them up here. Is array, is atomic, is call, is character, model, facet, factor, language, list, matrix, etc., etc. Date time, null. So that's very handy. We'll just go back to numeric. So if I say select product, select where is numeric, just give me the price column. Num range is the last one. I need a new table for this. So my nums is a table, row names, A, B, C. Column names are var1, var2, var3, and the data is just 1 through 9. Let's say select num range. I can break off the string part of this column and then select them by their number. So var1 and var2, that's pretty cool. Again, order doesn't matter. You can rearrange them. It's product ID, product name in our data frame, but my product select product name, comma product ID, just reverse it. And you can rename while selecting. So I could say select price equals product price. and that changed the column name to price. If I wanted to change the column name and keep the rest of the columns, also I would use a rename argument instead. The last thing you can do is just select by range, indexing kind of, select 1, 2, product ID, product name, select -2. This is a complementary exclusion. It gives you everything but column 2, which was product name, the middle column. Okay, that is about it for select. I've got to go back to PowerPoint here for a second. Got a slide about features of all three, ease of use. Tidyverse, very intuitive for R, highly versatile with many helper functions. It does require dplyr, the tidyverse. Its best use case is medium data sets in R, simple workflows. Pandas, straightforward but requires Python knowledge. Very limited. You have to have pandas, and it's used for data manipulation in Python. SQL is easy in SQL and the familiar SQL syntax. It's kind of limited also. You don't have to install any packages, and it's great for pulling stuff from a database. And a lot of the world's data is still in SQL databases. So that's it for select. Join me next time. I'll move into where and filter. I hope you liked this one. If you did, please like and subscribe, and I'll see you next time. Thanks, everybody.